Welcome you all in this session of fluid machines. We were discussing the centrifugal pumps. We have seen the important components of the centrifugal pump, the basic working principle of the centrifugal pump, and the velocity triangles for the centrifugal pump. We have also discussed the head imparted by the impeller to the water, which is given by impeller power per unit weight of water per second is equals to VW to U2 by G. So this is nothing but this is the head which has been imparted by the impeller to the water, and it is also known as the Euler head. Now we will discuss another important head, which is manometric head. Please note, the head which is utilized by the water, is known as manometric head. This is the total head imparted. This is the total head which has been imparted by the impeller to the water. Now this is the head which is utilized by the water, is known as manometric head. So head utilized by the water is known as the manometric head, or the head developed by pump. Head developed by pump is known as manometric head. Please note, these are the definitions for manometric head, but you have to understand the concept very carefully. So either head developed by the pump or head utilized by the water is known as the manometric head. Please observe very carefully. The manometric head can be written as H equals to, this is the total head imparted by the impeller, HE, Euler head, minus losses in guide vanes and casing. Please note, we need to understand the concept very carefully. This is the pump, this is the main pump. When I talk about the pump simply means impeller plus casing. Casing may consist of guide vanes, or it may be a simple volute casing, it may be a casing with guide vanes. Okay, so main pump means impeller plus casing. Please note, this pump is drawing water from the sump. It is drawing water from the sump and delivering to some point of delivery. Now please, this is the inlet to the pump denoted by I, and this is the outlet of the pump denoted by O. Now whatever the head has been developed by the pump, that is the difference of head between section OO and section IE is the manometric head. Means the manometric head can also be defined as total head at the exit of the pump, P naught by rho G plus V naught square by 2G plus Z naught minus Pi by rho G plus Vi square by 2G plus Zi. This is the total head which has been developed by the pump. The total head developed by the pump. The pump has developed this much of head. The total head at the exit of the pump is this. The total head at inlet to the pump is this. So the total head developed by the pump is the manometric head. This is one of the formula for the manometric head. The total head at the exit of the pump means impeller plus casing. Casing may be volute casing or casing may be with the guide vanes. So the total head at the exit of the pump is P naught by rho G plus V naught square by 2G plus Z naught. Total head at inlet to the pump is Pi by rho G plus Vi square by 2G plus Zi. Difference of the two is known as the manometric head. And when manometric head is written in terms of Euler head, it can be represented by this formula. Please note what is the meaning now of this formula. This is the head utilized by the water. The impeller has done this much amount, the impeller has produced this much amount of head, but some of the head will be lost in guide vanes and casing. So actually the water is utilizing this much amount of head. This is the head which has been imparted. This is the head. H is the head which has been imparted by the impeller to the water. But water will not be utilizing the whole head, because some of the head would be lost in overcoming the frictional losses in guide vanes and casing. Some of the head would be lost in overcoming the friction in guide vanes and casing. Therefore, the water will be utilizing only H, this much of head. Of this total head imparted to the water will be utilizing only this much of head, that is manometric head. So when losses in guide vanes and casing, the frictional losses in guide vanes and casing are subtracted from the total head imparted by the impeller, then we will have the manometric head. I think the concept is clear to you. Both the formulas can be utilized to determine the value of the manometric head. Again, I am repeating, please note. The first point is this: the total head developed by the pump is known as the manometric head. For that, I took the pump. Pump means impeller plus casing. Basically, pump means impeller plus casing. Now, this is the exit to the pump. This is inlet to the pump. This is the exit of the pump, inlet to the pump. Total head at the exit to the pump is this. Total head at the inlet to the pump is this. Difference of the two is the manometric head. This is the first definition of the manometric head. Another definition for the manometric head is, it is the head utilized by the water. Head utilized by the water. Since HE amount of head has been imparted by the impeller to the water, but actually this much amount of head would not be utilized by the water, because some of the head would be lost in overcoming the friction inside the guide vanes and casing. Therefore, the head utilized by the water would be less than HE, and it will be H equals to HE minus losses in guide vanes and casing. Okay, good. I think it is clear to you. Now, another formula for manometric head you can write. This formula I would like that you can yourself derive. The manometric head is also given by HS, that is suction head, plus delivery head, plus head loss due to friction in suction pipe. All the losses has been taken into account. In suction pipe, all the head losses in the delivery pipe, plus VD square by 2G. This is the another formula which you can derive yourself for manometric head. This is another formula for manometric head. Now please note one important point. Now let 1 and 2, if 1 and 2 represent the inlet and entry to the impeller, please, 1 and 2 represent entry and exit to impeller respectively, then one formula I can write by applying Bernoulli's equation. The difference of head between inlet and exit of the impeller. At the exit of the impeller, the head is, because 1 and 2 refer to the impeller only, P2 by rho g plus V2 square by 2g plus Z1. This is the total head at the exit of the impeller minus the total head at the exit of impeller at the inlet of the impeller. Sorry, this is Z2. This would be equal to the manometric head H. That is, sorry, this would be equal to the Euler head HE. That is head imparted by impeller. The head imparted by the impeller, that is the Euler head HE, would be equal to the total head at the exit of the impeller minus total head at the inlet of the impeller. Simple energy balance, head balance has been done. The head imparted by the impeller, which is the Euler head, is equals to total head at the exit of the impeller minus total head at the inlet to the impeller, and it will be VW2U2 by G. So please note a particular difference of 1 point. 1 and 2 indicate inlet and exit of the impeller. This is the total head at the exit of impeller, total head at the inlet to the impeller. So to the head imparted by the impeller, this difference of the two represent head imparted by the impeller, which is equals to the Euler head. While we saw I and O, they are the head imparted by the pump. I and O refer to the inlet and exit to the pump. Inlet and exit to the pump. Pump is impeller plus casing. So please note a difference. When we are talking about the head imparted by the pump, then it is manometric head. When we talk about head imparted by the impeller, it is the Euler head. There is a difference between the two. Now please note one important point, that the impeller power per unit weight of water striking per second is given by VW2U2 by G. This is the power available at the impeller, or you can say impeller power per unit weight of water striking per second is given by this formula. Now if I talk about the shaft power per unit weight of water, then shaft water will be somewhat more than the impeller power. Impeller power per unit weight of water striking per second plus losses, mechanical losses at bearings, etc. all the mechanical frictional losses would be taken into account. Means this is the power available at the impeller. We have to supply the power to the shaft, then shaft power would be more than the impeller power. So shaft power per unit weight of impeller is mounted on the shaft. Shaft power per unit weight of water striking per second would be equal to impeller power per unit weight of water striking per second plus mechanical losses at bearings. Mechanical losses at bearings. This indicates the power to be supplied. This indicates power to be supplied in the form of electrical energy. This indicates the power available at the shaft of the electrical motor. This indicates the power available or power to be supplied at the shaft of the electrical motor. So how the power flows? Power first goes to the shaft of the impeller, then from shaft to the impeller, and then from impeller to the water. That is how the power flows in a centrifugal pump. So this is the shaft power. Now we will talk about some of the important efficiencies, various efficiencies. So first was manometric efficiency. The first is manometric efficiency. Manometric efficiency. Please note manometric efficiency. So manometric efficiency of the pump is defined as the ratio of manometric head to the oiler head. It's very simple. Manometric head to the oiler head. That is head utilized by the water to the head imparted to the water by the impeller. This much is the head which has been imparted by the impeller, but water has utilized lesser head because some of the head has been lost in overcoming the friction inside the guide vanes and casing. Therefore, head utilized upon head imparted is the manometric efficiency. So it would be H is given by H is simply H is VW2U2 by G. So it can be written as GH upon VW2U2. Please note, this is the head imparted by the impeller. This is the head utilized by the water. Both are different because whatever has been imparted, of that some of the head has been lost in overcoming the friction inside the guide vanes and casing. Next is, the first is manometric efficiency, second is mechanical efficiency, eta mech. Mechanical efficiency is very easy. It is the shaft power or impeller power per unit weight of water striking per second divided by shaft power per unit weight of water striking per second, or you can simply write it is IP upon SP, impeller power upon shaft power. This is the mechanical efficiency, because shaft power is more than the impeller power over here, because power is first available at the shaft, then it comes to the impeller. Some of the power is lost in overcoming the frictional losses, mechanical friction losses at bearings. Therefore, the ratio of impeller power per unit weight of water striking per second to the shaft power per unit weight of water striking per second is known as the mechanical efficiency. And finally, third is eta overall, which is given by manometric head to the shaft power per unit weight of water striking per second. Manometric head, which is also the multiplication of eta manometric and eta mechanical. So these are the various efficiencies. Very easy.